Hello and welcome back to Pharma E-Class. I am Anindya Goswami from Smriti College of Pharmaceutical Education, Indore, and we were discussing the measurement of rate of fluid flow and pressure as a part of the flow of fluids chapter. Now we had come into the hydrodynamic methods of the measurement of the rate of fluid flow, and in that course of study we have covered orifice meter. Now we will study venturi meter and the rest of the different hydrodynamic methods. So this is the diagram of a typical venturi meter, or our topic is the measurement of rate of flow of fluids with the help of a venturi meter. Let us come to its principle. This is quite similar to an orifice meter, and there are with certain differences and with certain similarities also. So we'll first see its principle, then in the course of study we'll also discuss the difference between an orifice meter and a venturi meter. So the venturi meter consists of tapered sections inserted in a pipeline with the tapers smooth and gradual enough so that there are no serious loss of energy. That means if this is a pipeline flow, now we can impart or we can just insert the venturi meter in a form of a tapered section, but the tapered section should be very smooth and gradual so that it can allow the flow of the fluid without any serious loss of energy. At the point B, the section of the venturi meter has minimum diameter, and this point is called as the throat of the venturi meter. So if we consider this is the upstream pressure of the point A, and this is the point of the constriction where the venturi is being fitted, this particular constriction is called as the throat of the venturi, and this is all fitted within a streamlined pipe. So the pressure at the point A is the upstream pressure, and the pressure at the point B and beyond the point B is the downstream pressure. So this is the throat of the venturi, and that is actually the point where the venturi meter is being fitted. It is the tapered and smooth and gradual enough. So definitely the venturi meter is fitted within the pipe. The pressure difference at the point A and the point B is similarly or likewise like an orifice meter. It is also measured by the help of a simple manometer. So Bernoulli's theorem in this case also, it provides the basis for correlating the increase of the velocity head with the decrease in the pressure head between the 2 points namely point A and point B. And if you have seen from the diagram, it is evident that the manometer is connected to estimate the pressure difference between the upstream and the downstream, that is between the point A and in the point B. Now if the diameter of the venturi is compared to the diameter of the pipe, the velocity of the fluid at the point before entering the venturi may be considered as negligible, and in such cases manometer reading directly gives the velocity of the fluid. So this is another important point which is to be considered when we want to discuss a venturi meter. So this is the mathematical expression which is very evident from the Bernoulli's theorem again, and since there are practically no losses due to eddies, and since cross section of the high velocity part of the system is accurately defined, so we can define or we can equate the concept of venturi meter likewise, that is uv is equal to cv root over 2g into delta h, where uv is the velocity at the throat of the venturi meter in meters per second, cv is the coefficient of the venturi meter, and delta h or delta hp in summer we can also find, that is the difference in the pressure head from the manometer, that is in meters. So uv is equal to cv root over 2g into delta h. This gives the equation of the venturi meter, and this equation comes after we consider the different consideration aspects in the Bernoulli's equation. So delta h can be measured using a manometer, which is done, and it can be substituted in the above equation in order to get the velocity of the liquid flowing through the venturi. When the cross section of the pipe we already know or it is known, then the volume of the liquid per hour can also be determined, and in case of the venturimeter, the value of the coefficient, that is the coefficient of venturimeter CV in this equation, is given as 0.98. Let us come to its construction. Simple, inside a simple pipe this venturimeter is being fitted, and it is fitted likewise that this particular constriction point occurs, and that constriction point is point B, or it is known as the throat of the venturimeter. So a venturimeter consists of two tapered sections inserted into a pipeline. The tapers are smooth and gradual, as we have discussed earlier. The upstream cone is normally shorter. Look at the upstream cone. It is the upstream pressure from where the liquid enters or the fluid enters. So it is a bit tapered on it, and it is a bit shorter. And the downstream cone, that is this particular cone, it is quite larger, or it is quite lengthier. So eddies in the downstream is absent. Eddies or any sorts of formation of fluid air or entrapment of air, that particular eddies in the downstream is practically absent, and hence no power loss occurs. And it is a very basic assumption which is being considered when we have equated with the equation of the venturimeter. And obviously manometers are connected with the 2 points, that is point A and the point B. Come to its working. A venturimeter is referred to a variable head meter, that is, it measures the variable differential pressure across a fixed constriction placed in the path of flow consisting of a constant area. Now in a venturimeter, the velocity of the fluid is increased at the throat due to its constriction. Yes, this is the constriction point, and the velocity of the fluid just gets increased at that constriction point, and due to the result of that constriction only, this results in a decreased pressure in the upstream cone. The pressure at this particular point, it is a decreased one. So this is the reason, because there is a constriction where the venturimeter is fitted, and the pressure at this particular point or the upstream point is quite decreased one. The pressure drop in the upstream is utilized to measure the rate of fluid flow using a manometer. So come to the applications of venturimeter and its basic difference with an orifice meter. Now venturimeter is applied commonly for liquids, especially with water, whenever our testing liquid is water and we want to see the measurement, we have to measure the rate of the flow of the water, then we can use successfully a venturimeter. It can also be used for the measurement of gases as well. Its disadvantage is it is quite expensive, it occupies more spacing compared to an orifice meter, and the ratio of the throat diameter to the pipe diameter cannot be changed. That is another disadvantage which we didn't find in an orifice meter. So it is an expensive one, it occupies a little more space than orifice meter, as well as the ratio of the throat diameter to the pipe diameter cannot be changed. Now let us come to the comparison between the difference between an orifice meter and a venturimeter. First and foremost, in case of orifice meter, if we have studied in the previous classes, the installation is cheap and easy, installation is costly, it is less easier than venturimeter, so that is a disadvantage. Yes, it is an expensive machine or device. The power loss is considerable in long. In this power loss, it is being considered to be is considerable in the particular equation. Power loss is less in the long run, even negligible, so that is its advantage in case of a venturimeter. The orifice meter are best used for the testing purposes or other cases where power loss is not a factor. So in case of the orifice meter, we can only consider, or we can only successfully apply measure the rate of fluid flow where the power loss is not a factor as in case of the streamlines. Whereas venturimeters are used for permanent installation, and it is advantageous in that aspect also. And installing a new orifice plate with a different opening is a simple matter wherever installation of a different opening require replacement of the whole venturimeter, so that is a disadvantage. So this is all about a venturimeter and its basic difference between with a orifice meter.